How can robots manipulate objects in confined spaces? Imagine a robot squeezing into a tiny space, carefully picking up objects without knocking anything over. It sounds tricky, but with the right design and control, it becomes possible. Robots manipulate objects in tight spots by combining clever kinematic structures, precise sensors, and smart control systems. From an electrical engineering view, this involves using signal processing, sensor data fusion, and advanced algorithms to make sure the robot moves smoothly and safely. First, robots meant for small spaces often have flexible or reconfigurable parts. These allow the robot to change shape or reach around obstacles. Engineers design joints with multiple degrees of freedom, which means the robot can move in many directions. Actuators and sensors are built into these joints to control their movement accurately. Sometimes, the robot's arms are made to be compliant, meaning they can bend or give slightly when they touch something. This helps prevent damage and makes the robot safer to work with. Next, sensing is key. Robots use for sensors, tactile sensors, and proximity sensors along their arms to feel what they are touching. These sensors send signals to the control system, which filters and interprets the data in real time. This process helps the robot understand where contact is happening, how much force is being applied, and what obstacles are nearby. Combining data from different sensors, a process called sensor fusion, makes the robot more reliable in uncertain environments. Control systems then take this sensor information and adjust the robot's movements. They use algorithms that manage both movement and contact forces at the same time. This allows the robot to push gently against surfaces or grip objects firmly without slipping. The system constantly updates commands to the motors based on feedback, keeping the robot stable and responsive even in tight, cluttered spaces. In many cases, robots work alongside humans in confined environments. Electrical engineers develop safety features like compliance control, which makes the robot more adaptable and gentle when interacting with people or delicate objects. These robots can detect unexpected contact and adjust their actions instantly, making collaboration safer and more effective. In real-world applications, these robots are used in manufacturing to handle parts in cramped assembly lines, in inspection tasks inside pipelines or reactors, and even in search and rescue missions where they navigate through collapsed buildings or narrow passages. They can manipulate tools or sensors precisely, even when space is limited. In summary, controlling a robot to manipulate objects in tight spaces involves a mix of smart kinematic design, sensitive sensors, and advanced control algorithms. These elements work together to allow the robot to move accurately, feel its environment, and interact safely within complex, confined areas.